Hello everyone and welcome back to my YouTube channel or David Structure Hub, and this is the #1 channel for structural insight and a place where you learn, build and innovate. So this is session number 3 under design of reinforced concrete to Eurocode 2. So we are still under introduction, and it is a must. We have to go through these theories so that you can get the basis of this code. So these are the best notes that you can never find them anywhere apart from this channel. And I'm breaking every complex concept into a simpler concept so that you can understand every word, every formula, and every vocabulary used in this Eurocode 2. So today I want to talk about combination expression. So combination expression, let me write it on the board. So when I'm talking about the combination expression, I'm talking about the loads which will be acting on a structure. As you know, we have different loads acting on a structure. For Eurocode, we have a permanent actions, which is the same as the dead load in the other code, which is BS 810. And we also have the variable loads, which is known as the imposed or live load in the other code. And we also have the wind load. So the wind remains the same. So you want to see how you can combine this loading and come up with an expression that will give us the design load or the design action, probably is the design action in this Eurocode 2. So according to EN 1990, the design values of action effects, assuming the structure is subjected to both permanent and single variable. For example, this is the dead load plus imposed load, or a dead plus wind load, can be assessed using the following expression. So this is the expression which is used to assess the design value of action effect on a structure subjected to permanent and single variable action. So if you go to a Eurocode 2, you will find this expression there, but I have broken it down for a simple understanding. So if we go to plus, so it means whereby the plus, which is this one, it implies to be combined with, and then this one, it implies the combined effect, and then ed, which is this one, is the design action or the design effect load, and then you have gkj, which is this one. So it is the characteristics value of permanent load J, this one. And then we have the this one, which is here. It is here. So this is the partial safety factor for a permanent load J, and it is probably 1.35. And then we have the QK1. QK1 is here. It is the characteristics variable loads or live load. And then we have this one is here. So this is the partial safety factor for the variable load. So using the partial safety factor given in table 8.7, the design value of action effect is given by this formula. So this is the design action. This is the design action, or the design value of action is given by 1.35 GK plus 1.5 QK. So this is load combination 1 and 2 from table 8.7. I think I can show you the table so that you can see how this 1.35 is obtained from the table and 1.5. Let me show you the table. So this is table 8.7. As you can see, you have the permanent, which is GK imposed, QK, and wind, WK. You have this table. So for the permanent and the variable, we have for the combination of permanent and variable. If we begin with permanent, which is GK, we go for unfavorable. As you can see, it is 1.35, and then we come to the imposed load, so it's 1.5. So in other words, if you combine, it will be 1.35 GK plus 1.5 QK. So these are what we call the partial safety factors for the ultimate limit state. So that is it. So in BS 8110, the design load is equal to 1.4 GK plus 1.6 QK. So this is for BS 8110. We always use this formula for the combination between a dead and imposed. So let's proceed. In our first expression, which was expression 8.6, the expression was for a two combination loads, which is a permanent action and a variable action, which is a live load or a wind load. So we want now to see three combination loads or actions, which may be permanent and two or more variables actions. So the two or more variables action can be the wind action or the live load action. So the design value of an action effect due to permanent and two or more variable actions. Example, we have the dead plus imposed plus wind is obtained from expression 8.7. So it's obtained from this expression, and this is the expression. So this is the expression. So point to note, this expression, it yields two or more estimates of design action, and the most onerous should be selected for design. So onerous, it means the one which has the highest effect on the structure, or the worst design effect, probably is the worst design effect, should be selected for design. So for example, if a structure is subjected to permanent, so this is the GK. Let me write it using another pen. So this is the GK, and office is the imposed load or the variable action, which is QK, and wind action, the wind is WK of GK, QK, and WK. The values of action are, so these are the values of action. So this one is for this is the design action effect, is given by 1.35 GK. So 1.35 is the partial safety factor. J plus 1.5 QK. So 1.5 is the partial safety factor plus 1.5. Again, this 1.5 is the partial safety factor for wind times 0.5 WK. So how do you obtain, or how is this 0.5 here? So it is because we have two variable actions, of which we have the QK and the WK. So this QK is the leading action. This QK is the leading action or the primary action. And this WK is the secondary action or accompanying action. So it is accompanying this QK. So for such accompanying action, which is WK, the code says that these two cannot reach, which is WK and no, QK and WK cannot reach maximum at the same time. So it has shown that this QK, which is the first variable, will reach maximum before this. So it means this WK, it is supposed to be multiplied by this factor. And this factor is a factor which is in a table. I think it is table 8.8. And I'm going to show you how this factor is obtained in the table, which is 0.5. So let me show you. So this is the table 8.8, values for combination load, and 2, we have the quash value. So if we proceed to where the wind is, as you can see the wind load, just see where my cursor is. So the wind load is 0.5. So the value of this, of the combination, is 0.5. Is 0.5. So the value is 0.5. So as you have seen from the table, for the combination value is 0.5. So you will multiply the wind load by 0.5 because it is accompanying a variable or the secondary variable. So we have to reduce it by multiplying it with this value, which is 0.5, because they will not reach the maximum with QK at the same time. The same will apply to this second formula. So this is load combination 3B, table 8.7. And let's go to the second expression, which says that the design value effect is equal to 1.5 GK, J plus 1.5 times 0.7 QK. So this is the partial safety factor, as well as this one. So this is load combination 3C, table 8.7. So why are we using these two expressions? We are using these two expressions because you are supposed to obtain, or to use the one that gives the higher bending moment shear or load effect. This is the one which will be in worst design effect. So the one that will be in the design, in the worst design effect, is the one that will be used for the design purposes. So you have to check between the two. So the second expression, which is this one, so we assume now this wind load is the leading action. This wind load, this one, is the leading action or the primary action. And then the QK will be now the secondary action. So it means these two will not reach maximum at the same time. So we are shown the WK will be the first one to reach the maximum, and then this will be the last or the second. So we will multiply the second one, which is accompanying variable, times the value of this combining value. Again, we'll proceed to table 8.8 and obtain the value for impost. Remember, the impost is office. So we proceed and check the value here for the impost, which is office. So again, I'll show you the table. As you can see, this is the table. So we proceed to office. You can see the office is 0.7. So the value there is 0.7. So the value is 0.7. Here it is 0.7. So this is load combination 3C, table 8.7. So point to note, as I have said earlier, use the one that gives the higher bending moment, comma, shear, or a load effect, in bracket, worst design effect. So that is a load combination number 2. So let's proceed. Equation 8.6 and 8.7. You have seen this. So equation 8.6 is the first expression, which was for the permanent action and one variable only. And then 8.7 is for the permanent plus 2 or more variables. So the two equations are based on expression 6.10 in EN 1990. So this document also includes two alternative expressions, namely 6.10a and 6.10b. So reproduced as 8.8 and 8.7 respectively for calculating the design values of actions, use of which may improve structural efficiency. So these two equations can improve the structural efficiency, particularly for heavier structural material such as concrete. So this is the expression. We start with expression 8.8. So don't worry about the symbols that are here. So I have break them down. So this is the breakdown of the terms in this expression. So if we begin with this one, which is here, so this one, it means is the sum of all unfactored dead loads, or which we call the permanent action. The permanent action is for the EC2 or Eurocode 2, and the dead load is for the it is a term used in BS 810. So it is the sum of all unfactored dead load multiplied by partial factors. And then we proceed to number 2, which is this term or these symbols. So it is here. So from the QK, it means is the variable action, or in the BS 810 is the live load or the imposed load. So this is the leading action. So this is the leading action like live load or wind. And then we proceed to the third one, which is this one. Here it is. So all accompanying variable actions, example include snow plus wind plus live load. Then number 2, you have live load plus thermal plus wind. Each will be reduced by its combination factor, which is obtained in table 8.8, and multiplied by, this is the partial safety or factor for this variable action. So this is expression 8.8. We now proceed to expression 8.9. Now this is the expression 8.9 or equation 8.9. So what will change here is this one. So in the first equation, we didn't have this symbol. So this symbol, it means is a reduction factor for unfavorable permanent actions. The value of this recommended in national annex to Eurocode 2 is 0.925. And then a point to note, equation 8.8, it yields only one estimate of design action, i.e. load combination 3A in table 8.7, whereas equation 8.9, it yields 2. It yields 2, i.e. load combination 3B and 3C in table 8.7. So the use of equation 8.8 and 8.9 may improve the structural efficiency. So the use of these two equations may improve the structural efficiency. Now let's talk about the loads arrangement. So this one is discussed in section 3.6.2, design of continuous beam and slabs. So this one is discussed in section 3.6.2, design of continuous beams and slabs will require consideration of loads arrangement. So you have to have a proper loads arrangements. So this term refers to the way in which variable actions should be positioned in order to produce the most onerous design condition. The national annex to Eurocode suggests two alternatives loadings arrangement for a continuous beam. So this is load set 2A, and the 2 is the load set 2B. So you can arrange them in such a manner or in such a manner. So load set 2A can also be used to determine the design conditions on continuous slabs, provided the following assumptions are satisfied. So Roman 1, in one way spanning slab, the area of each bay exceeds 30 meters square. And then Roman 2, the ratio of the characteristics variable loads to characteristics permanent loads does not exceed 1.25. And then the last one, the characteristics imposed load does not exceed 5 kilonewton per meter square, excluding partitions. And then the last statement, which I have not captured on the board, it says that according to the national annex to Eurocode 2, when the slabs are analyzed using the load arrangement, the resulting support moment, except those at the support of cantilever, should be reduced by 20% moment. So this is step 1 of annex to Eurocode 2. So you will see this table later. So that marks the end of today's topic, or no, today's session. So thank you for your time, and just a reminder for those who have not subscribed to the channel, subscribe and hit the notification bell so that you may be the first person to be notified. So let's meet again in my next session. so that we can continue with this introduction. So thank you for your time.